Factor the following trinomial, if possible. We know that to factor a trinomial that has a leading order term that's not 1, one method that we can choose to use is to look at the product of that leading order coefficient and our constant term. So look at the product, -10 times 35, and try and come up with factors of that product that sum up to be our coefficient of our single variable term, so our y term. So I'd like to come up with two factors of this product, -10 times 35, so -350, two numbers who sum to 11. Instead of working with -350, what I'd like to do is break these up even more. I'm interested in factors. All right, I want two factors. So if I break these down into their prime factorization, 2 times 5 for 10, and 35 is 7 times 5, into their prime factorization, I can easily see what factors of the product -10 times 35 are, what factors of -350 are. I'll just pick 1 or 2 or 3 or all 4 of these numbers, multiply them together. That's one factor. Take whatever's left over, multiply them together, that's another factor. Those two numbers, when I multiply them together, will give me my -350. So let's pick a couple. I could say take, well, first off, I could take 10 and 35 themselves. Think about those as factors. One of those needs to be negative. So I'll say that one's negative. Well, those don't add up to +11. What else could I do? I could take, say, 2 and 7, multiply them together. Let's make one of them negative. What's left over? 5 and 5. What's that? 25. What's the sum here? Oh, look, that works. 11. So I know that, let me get a different color pen for a second. I know that if I take 14 times y and 25 times y and add them together, -14 times y, and add them together, I'm left with a +11y. This tells me a way to rewrite this 11y that showed up there. So let's do that. We'll rewrite that 11y. So I can write that polynomial equals 35y squared plus, instead of 11y, I'm going to write 25y minus 14y minus 10. Now I can do some grouping. So let's go ahead and group. I'll go ahead and group these two things together. I'll go ahead and group these two things together, being careful with my grouping and that negative symbol, right? I don't want to group things and change the signs of other things. All right, so 35 times y squared, 25 times y squared. Common factor, I got a 5 in both terms. I got a y in both terms, so I can factor a 5y out. What do I have left? 5 times 7 is 35, so I have a 7. Y times y is y squared, so I have a y left. Here I factor a 5 out of 25. I have a 5 left. I factored the y out, so that's gone. Over here, 10 and 14 are both at least even. They have a 2 in them. I can pull a 2 out. I don't like leading order negative terms, so I'm going to actually pull a -2 out. Take a -2 out of a -14y, I'm left with a +7y. Pull a -2 out of -10, I'm left with a +5. Look at that, 7y plus 5, 7y plus 5. Same factor showing up in both of these two terms. That means I can pull it out. So I have 7y plus 5 times, what's left over? I got a 5y minus 2. And that is my factored form. If we were a little unsure about the work that we did, we can always check this factored form, right? 7y times 5y, I'm foiling here. 7y times 5y is 35y squared. 5 times 5y is a 25y. 7y times -2 is a -14y. 5 times a -2 is a -10. And of course, 25y minus 14y, that's the 11y that we were looking for earlier. That's why we came up with this breakdown, because when we do this checking, when we do this foiling, those are the terms that show up. So this factoring checked, we have an answer, we're done.